Good morning, everybody. Today we'll discuss on the topic relation between a radius of sphere and size of words. We know during close packing there are two types of words are caught: tetrahedral words and octahedral words. So the relation between radius of sphere and size of words. Size of words means size, that is tetrahedral words and octahedral words. Let us first discuss octahedral words. We know octahedral words generally produce between 6 spheres. So this is your octahedral words already discussed. If you see this one, the model is like this, similar model. Over 3 spheres, another 3 spheres are placed. If you see the words is produced in between these 6 spheres, 3 spheres above another 3 spheres. If you look these 6 spheres, four spheres are visible. 4 spheres are visible towards front, and back also another 4 spheres are there. If you see, 4 spheres will be visible from the front. So the words can be represented in the plane like this. So this is the words. This is your words means the smallest atom present in the words, and these are the spheres. So let these are joined like this, and the radius of sphere written as capital R. This is one R, another R. This is also one R. This is also one R. And here one R. Then these spheres which present at the words, at octahedral words, it is small r. This is also small r, and it is your capital R. That means if you draw the line, here three spheres are coming in contact. So this is A, this is B, this is C. Then let us derive a relation that we know this is example of a right angle triangle. So AC square in the triangle ABC. AC square is equal to AB square plus BC square. AC square, in AC how many spheres are coming in close contact? Here three spheres. In AC, three spheres are coming in contact directly. First one, second one, that is voids, third one is the sphere. So you consider all the radius. Here 1r, here 1r, that is 2r, plus here the small, that the voids where the sphere is occupying, that is 2 small r. 1r, here another r. Whole sphere has 2r. Then 2r plus 2r square is equal to AB. AB, you see the radius. AB has 2r. And BC also 2r. Then if you see that 2r plus r square is equal to 4r square plus 4r square. Then 4r plus r square is equal to your 8r square. Then r plus r square is equal to 2r square. Then come to here. Now r plus r is equal to root 2r. Now divide r in both sides. R plus r by capital R is equal to root 2. If you bring r to the left side, then it will be r plus r by r equal to root 2. Then it is, if you divide r, it is 1 plus r by capital R is equal to root 2. We know the value of the root 2 is equal to 1.414. So small r by capital R is equal to 1.414 minus 1, which is equal to 0.414. Now small r is equal to 0.414 capital R. This is the relation between small r is the size. This is the small r, that is the size of voids, and your capital R is the size of sphere. So radius of or size of voids is 0.414 times of the radius of sphere. That means here, as the size of voids is smaller than the radius of the sphere, so it is how much times? 0.414 times. Then this is for octahedral voids. Similarly, if you derive the relation for tetrahedral voids, the relation will be different. Take suppose you see tetrahedral voids generally produce, already know, between and these are the cubes where one sphere occupied are the voids, that is the tetrahedral voids. You can take this is, and this is the sphere occupied at the corner. Then at this corner is like this. You join this one and directly to this. So it is just like a tetrahedron. This four coming just like a tetrahedron. Just imagine the corner point. Imagine this is the corner point. This is the corner point like this. Or this is the corner point. Other three spheres are like this. One sphere are the body center and other are corners. So you just, it is a shape just like triangle. You take this is A, this is B, and this is your C, this is your D. So this is the, you can say, the shortest distance can be determined from this point, because maximum spheres are coming in this line. That's why we have to derive the distance from this line, because it will be the shortest distance. It is clear? So we know the triangle ABC. The triangle ABC. AB square is equal to AC square plus BC square. And your AP square, that will be, you know, this is the side of the cube, this is A, and it is also A. This side is A and this side is A. So AP square is equal to A square plus A square, that is 2A square. So AB is equal to root 2A. So this is equation 1. Now come to, that is your ABD, triangle ABD. The triangle ABD, AD square is equal to AB square plus BD square. AB square is equal to 2A square and BD is also A, because the edge length of the cube, that is A square, which is equal to 3A square. Now AD is equal to root 3A. This is your equation 2. Now you see in AB, you consider this is the voids and these are the spheres. So A, B and D. AB, it is shown like this, but the spheres are coming in contact. They are closely placed. So if they are closely placed, then the radius will be capital R and this is your capital R. So AB is equal to root 3A and AD is equal to root 3A. So equation 2 by equation 1, what you will get? Equation 2 is AD contain 3 spheres. AD, this is for AB, this is for AD. AD contain 3 spheres. 3 spheres means here one R is a small r and capital R. That is AD equation 2 by equation 1, that is AD is equal to 2 capital R plus 2 small r. So 2 into capital R small r upon AB. AB is equal to 2 capital R. 2 capital R is equal to here root 3A by root 2A. We are dividing equation 2 by equation 1. So it will be R plus R bar capital R is equal to root 3 by root 2, which is equal to, we know, root 3 is equal to 1.732 and root 2 is equal to 1.414, which is equal to 0.225. This is 0.225. So now R plus R now it will be R plus R by capital R is equal to 0.225. Now R plus R, you will divide R. It will be 1 plus R by R is equal to 0.225. Now small r by capital R is equal to, it is not 0.225. It will be, it is greater than, numerator is greater than numerator, it is 1.225. It is 1.225. So just to write 1.225, it is 1.225 because 1.732 by 1.411 is 1.225. Numerator is greater. So R plus R is equal to 1.225 minus 1. The result is equal to, so R by R is equal to 0.225. Now small r is equal to 0.225 by capital R. So this is the relation. Small r is the size of birds and capital R is the radius of spheres. So now small r is equal to 0.225 capital R. If you compare in case of octahedral words and tetrahedral words, if you again discuss this word size, in case octahedral words, that small r is equal to 0.414 capital R, and r is the size of words. And here in case tetrahedral words, your small r is equal to 0.225 capital R. If you compare these two, which is greater? Which words is greater? This is the octahedral words, this is the tetrahedral words. If you compare this, the octahedral words always greater than your tetrahedral words. If you compare the size of words, this relation shows that octahedral words is greater than your tetrahedral words. How time greater, you can also derive this relation from this. If this is equation 3, this is equation 4, then if you take that this is your words of the octahedral, this is your tetrahedral. So if you take RO by RT is equal to 0.414 by 0.225. So this indicates, as it is greater than 1, this indicates the relation between the octahedral words and tetrahedral words. So always octahedral words is greater than the tetrahedral words. Okay, thank you.